Hello, this lesson is a lesson on probability. You probably have some intuitive understanding of probability to begin with. If I were to ask you what's the probability of drawing a king from a deck of cards, you would be able to answer that, I would presume. Say that there's a 4 in 25 chance. You might even be able to go directly to 1 in 13. When you think about there being the 4 suits and 1 king in each suit, you might go directly to 1 in 13, or get to 1 in 13 by simplifying 4 over 52. So we need to talk about a little bit of the terminology that goes with probability. For one, when we talk about probability, we are distinguishing between experimental probability and theoretical probability. So in theoretical probability, or I should say in experimental probability, we are going through the process of, say, flipping the coin. So if we want to know what's the probability of getting heads in a coin flip, we flip the coin 100 times and see what the outcome is. In theoretical probability, we are looking at filling in the equation for the probability of an event based upon the number of events that match a desired outcome over the total number of outcomes. So you can see that up here, what you did with the probability of drawing a king from a deck of cards. This was the number of events that match the desired outcome of king, and this was the number of total possible outcomes. This number of total possible outcomes has a name that we should be familiar with. It is called the sample space. So that is the total number of possible outcomes when we're looking at the probability of an event. And all probability really does come down to this question here, filling in that formula. Now there are some nuances in here that we are going to address, and I think the best way to do that is by way of some examples. So here is a problem. We're going to roll 2 dice, and we are going to see what's the probability that the sum is 7. So I'm going to be looking for the probability of a sum of 7, and I want to look for how many outcomes match the desired probability and how many possible outcomes are there overall. Well, let's take a look at what it looks like to roll 2 dice. Let's start off with the number of possible outcomes. So that's a fundamental counting principle problem, right? There's 6 ways for the one of them to come out, and then there's 6 ways for the other one. So it's going to be a total of 36 possible outcomes. Now, how many of those match my desired outcome? These I just have to start listing these out. So I can look at a 1 and a 6, and then I would also have 6, 1, and then I could have a 2 and a 5, 5, 2, and 3, 4, 4, 3. So 6 of the 36 outcomes are going to be sums of 7. So that's a 6 in the numerator, and I get a 1 in 6 chance of rolling a sum of 7 with 2 dice. A couple of things to note in this problem are, 1, we used a counting principle, and this is very common in probability problems to use counting. And the other thing is that we listed out all of the possibilities, and this is another common thing that you will do in counting problems. Okay, in this problem we're looking at the probability of drawing 2 red if I've got 2 red, or 4 red, 3 yellow, 5 green, and this could be like 5 or 7, 12 marbles in a bowl, and I've got 4 red, 3 yellow, 5 green, and I'm going to draw 2 of them without looking, and what's the probability of 2 red? So the way that I'm going to do this problem, I'm actually not going to do it in this way. I'm not going to do it as the using the formula. So we're going to introduce a little bit of a new principle here. I mean, could we think about all of the different ways that there are to draw 2? What would it be? I guess it would be 12 choose 2. And then we could look at all of those ways that match the desired outcome. But there's an easier way to do this. The way that I'm going to do it is I'm going to say the probability of 2 red is equal to the probability that the first marble is red times the probability that the second marble is red. So when I have a probability that involves 2 subsequent events, or if there are 2 parts to the question, I can find the probability that both events will occur by doing the probability of one times the probability of the other. So if you stop and think about this, maybe you could answer this question. What's the probability that the first marble is red? Okay, so maybe you said that there is a 1 in 12 chance because there is a 4 in 12 chance because there are 4 red marbles and there are 12 total marbles. So actually, within finding the probability of these 2 independent events, I actually am using this, right? So I actually am using the number of possible outcomes, total outcomes, and the number that match my desired event within this calculation. And then the second part, see if you can answer that. What's the probability that the second marble is red? Okay, so there are 3 red marbles left, 11 marbles total left, and I'm going to end up with, I'm going to simplify this to a 1 in 11 chance of drawing 2 red marbles. So let's continue with this and say we're going to do the probability of at least 1 red. So we're still going to draw 2. So we're going to draw 2, and we're going to say what's the probability that at least 1 is red. So I could get 1 red, or I could get 2 red. All right, so let's take a look at that. The probability of at least 1 red is going to be equal to the probability of 2 red plus the probability of 1 red. Does that make sense? So the probability that at least 1 red is going to take into account 1 red or 2 red. All right, so 2 red we've already got. That's a 1 in 11 chance. And then for the probability of getting one of them red, we're going to see that I'm going to use the counting principles. I actually alluded to this earlier, that we could do this as 12 choose 2, if you're with me down in the right-hand corner. 12 choose 2 is all possible ways to draw 2 marbles. Now I want to know, I want to count how many ways are there to draw one of them red. All right, and that is going to be 4 ways to choose a red marble, which will leave 8 ways to choose a different marble. And then we're going to work out that calculation. All right, so here are some of these calculations worked out. 1 over 11 plus 32 over 12 choose 2 is 1 over 11 plus 32 over 66, and this is all going to simplify to 19 over 33. want to show you another approach to this, which is convenient when you're dealing with a small enough scenario. I'm going to use what's called a probability tree. And in this one, I'm going to say that there are two strands here. One is the probability of a red, and one is the probability of a not red. So when I do an apostrophe here, that means not. So I got a red, not red. So what's the probability of red if I draw from these marbles? It's going to be 4 in 12 chance of getting a red marble, and there's going to be an 8 in 12 chance that I don't. Then I'm going to look at this next level. I'm going to do red, not red. Now what's the probability on this next level of getting a red marble? Well, if I already drew one above, now I'm down to 3 marbles, and there's 11 total marbles left. And then if I went not red on this level, there's 8 non-red marbles left out of 11. And then I'll finish the tree over here for red, not red. And the red, I still have 4 left if I didn't pick a red marble there. So I did not pick a red marble. So on the next level, there are still 4 red marbles and 11 total marbles. And here I was down to 7 and out of 11. Now to calculate the probability, what was I trying to do? I was trying to do the probability of at least one red. At least one. All right, so that's going to be, where are the paths that lead to one or more red? All right, so this path here, that leads to 2 red. This path here is going to lead to 1 red and 1 not red. This path here is going to lead to 1 red, and then this last path would be not red, not red, so I don't want that. Now the sum of these, well, first of all, I'm going to get to the bottom of a path, to figure out the probability of this path, of this pathway. So you see there's 3 pathways here, this pathway and this pathway, and then I'm going to add those. All right, now to find the probability of the pathway, it's a product. So I'm going to multiply the 2 probabilities. So this is going to be 12, 132. This is going to be 32, 132. And this is going to be 32, 132. All right, and then I want the sum of all of those. So that's 60, 76 out of 132. And that does in fact simplify to 19 over 33. So you see that was an alternative way of doing that problem. All right, so let's see if we can get in one more idea here, and this is the idea of the complement of an event. All right, so this is complementary probability. I'm going to go back to the 2 dice. I'm going to say, what's the probability that I get a 10 or less? Now, it's the same kind of the same as the previous page, where I was doing the sum of probabilities, right? So I was doing the sum of one probability of 1 plus the sum of the plus probability of 2. So what would happen here is I would go, well, what's the probability of getting, I guess, 2 plus the probability of 3 plus the probability of up to a sum of 10. And instead of doing that, I can do the complement and say that all of this is equal to 1 minus the probability of 11 plus the probability of 12. Now there's 2 in 36 ways of getting 11, and there's 1 in 36 ways of getting 12. And you see now I only had to do 2 easy calculations to get my final answer, as opposed to doing these 10 or 9 calculations up here.